Here are some first steps when dealing with data in the context of Pandas Dataframes. The first thing we need to do is we need to get access to our data. We need to import them into our programming environment. So the way to do is to first use the functionality from the Pandas package that we're going to need. So from Pandas, which is already installed in your Anaconda distribution, we can use import something called read sub CSV, which is a function to read CSV file format. So we introduced that function. It's now activated. We can use it now. And to use it, we just call it. So it's read CSV. And we need to have data that we will put as an argument to this function. The only caveat is that the data need to be in the right format. So let's have a look where my data are. I'll just expand to see my folder. There's a subfolder called data in my case. And if I open it, you can see among many other things, there's also a data file called Everlease data, which we're going to use. So I remember that name, Everlease subdata, and it's in the file format called CSV. This is just plain ASCII, and in each row, the numbers that represent the data are separated by comma. So CSV for comma separated values. Go back to this folder where I am and hide this for the moment. So we need to provide the name of the data file with the correct path to it. So the name needs to go into quotes because it's interpreted as a string. And then my subfolder was called data. And because I'm on a Mac, I used the / to refer to that data file. And you see, if I type the first letter, it auto-completes. On a Windows computer, you will probably have to do a \. If you are in doubt about the correct path, if you have it here, you can see, if I just expand it, the path is also highlighted here at the top of the Jupyter Lab notebook. So if I execute this command, I'll have it read, right? So I can see the data and now import it, and I can see them here. But of course, in order to handle them, we need to assign them to a variable. And just for convenience, I call this variable df, short for data frame. And to see the contents of the data frame, I just type df and I execute the code. The result will be the same. And we look at the outcome, the whole thing. The whole data frame is now containing 17 plus 1, 18 rows, 2 columns, and they are supposed to contain the concentration of the calcium ions and sodium ions taken from blood samples of patients with something called Everlease syndrome. Right, so that was the way to access data. If you have them in a CSV file, import them, read them into something like df, and df is our Pandas data frame. If you have your data in an Excel sheet, you can do two things. Either you can export them to a CSV format. This was an export functionality within Excel. And if you want to use Excel directly, you will find, checking the documentation of Pandas, that there is a read Excel function as well. So you can read sub Excel. If you import that function, you can get it directly from an Excel sheet. Now that we have the data frame imported, we can look at it, for example, to get an overview. We refer to data frame by its name, and then we say dot. And we use a function called head, followed by a square of parentheses, which can be empty at the moment. We don't need to provide an argument. and head will just give you the first 5 lines of that data frame. So how many columns you have, all will be shown, but only the first 5 rows. If you think that's not enough, the parentheses will take an argument, and incidentally the number of rows that you can see can be provided as an argument here in that pair of parentheses. So if you specify 10, what you will get as an output, you will see 10 rows of that data frame. So that's a way to get an overview, see all columns, but only the first few rows using head. If you want to know how many rows there are, you use a function that you know already, which is len for length. And if you check the length of the data frame, you will get as a response the number of rows in that data frame. So similar to what you would expect from a nested array. So this is the number of rows. How do you get the number of columns? So the same, you use length, but instead of just putting df, which only will give you the number of rows, to check the columns, you can actually say df dot columns, and if you now get the length of this, it gives you the number of columns in response, in this case 2. Right, so you have a way to access the number of rows and a way to access the number of columns. Of course, if you want to get that in a single line rather than doing 2 commands, you're not using length, but you're using shape. So df.shape without any parentheses gives you 18,2, which means 18 rows, 2 columns. It's provided as a tuple, and you remember the immutable tuple. Of course, the shape of a data frame is not something that you might want to change. You just want to know how many are there of each. I would also like to show you how to access the contents, the numbers, the individual numbers in that data frame in a very specific way. Namely, I want to introduce a notation that is very similar to what we are going to use later when we access data from NumPy arrays. And in the context of a data frame, which we have here, this can be achieved by using iloc. Loc for location and I for index, so the index of a location. And if we use .iloc, then we can use it in a convention which we'll use later, which is a pair of square brackets, and within the pair of square brackets, first the number of rows and then separated by comma the columns that you want. So if you want to see all rows, you put a colon, you remember that already. And if you want to see all columns as well, put another column. So that's all rows, comma, all columns. And that's how you get those numbers displayed on the screen. And of course, maybe we want to make a slice here, so we can use iloc and then slice, and the slicing conventions are the same that we used for lists or for nested arrays. And so like you want to see rows 2 to 3, you say 2 to 4, and that's the row's index, right? I stands for index 2, which is the third row actually. So if you want the second row, you start from index 1. If you want to see the second and the third, you say up to 3, and then comma, say all columns. So that's how you get the second and the third row, indices 1 and 2, and you get all columns in this case. If you want to see only the first column, use the same code. I'll just copy and paste it here, and you say 0, which is the first column, and there you have only the calcium values of those 2 rows that you specified. Right, so that's nice. One of the advantages of having data not just in this way accessed, but having data in a data frame is that maybe you remember that we saw that in a data frame each column has a name. One of the advantages of having data organized in a data frame, if you remember our head, and that was the first lines, and you can see here that both columns have a name. One is calcium, one is sodium. So if you know those names, you can also access the data via the name. So let me show you how to do this. So you specify which data frame, in this code called df, and then followed by a pair of square brackets. You can put that name directly, but you need to put it in quotes because it's a name, as if it was a string. And then if you say calcium, which is the name of the first column, then you get all the values in that column by referring to the name of the column. So that's a good thing that we can use. For example, this is a way of access to each of the numbers when we go through a for loop. Right? So we can go through a for loop that takes in each of the columns one by one and does some operation on them. And then we can get access to the numbers in that column by referring to them in the way that we just highlighted, referring to the name of the column. Now that we know how to access the numbers in each column by referring to its name, we can see how we can exploit that in a for loop. Let's first see how the for loop works. So I say for col in df, new line indented, and this will give us access to the columns of the data frame. But let's first check what we get by saying print col, and executing the code shows us we don't get the numbers, we get the names of the columns. And if you check the type, it's a string. So we can use that knowledge, the name of the column, by referring also to the numbers. But we need to expand the code a little bit. So we do the same iteration through the data frame. And instead of looking at cols, we look at the data frame of the column with that name. But the name is col, so we put that in square brackets following the name of the data frame. And if we execute this code, you can see we get two outputs for each column. First we get all the calcium values, 0 to 17 here, and then we get all the sodium values, 0 to 17. So that for loop now in that convention gave us access to all of the numbers in that data frame. And if I copy the code, of course, then once you have access to all those numbers, you can slice them. So you can select a few of them, and you do that by putting a second pair of square brackets, and then whatever you like to see. If you want to have the first three of those numbers, then you can see the outcome of this code now with colon 3 gives you the first number of the calcium, first three calcium values and the first three sodium values. Now that we have access to each of those values, we can of course do something to them, like get the mean or the standard deviation or whatever you want to calculate. Actually, you don't need to calculate the basic things that we want to know about the data frame, because you can access them directly from within Pandas by using describe. The describe function is a way to give you access to the most basic statistical features, and we'll just check what it does. So if we execute the code, we can see that this gives you a column. That this gives you two columns with a couple of rows. Columns have the names as before, calcium and sodium, and for each of those columns it gives you the count, the mean, the standard deviation, and so on. So count means just how many rows are there. Mean means the mean value of that column. So the calcium values will have a mean of 3.1, and the sodium values will have a mean value of 115.1. 1, 6, and so on. Standard deviation, you probably know what it is. If you have the 50% value here, somewhere in the middle, that's the median, and then 25% quantile and 75% quantile, as well as the minimum value, the smallest in that column, and max, the largest value in that column. Interestingly, if you look at the outcome of this, you can assign it to a name, to a variable name, and then you can check its type, and what you will see is that the outcome of describe is Pandas data frame as well. So all that we said previously about accessing items from that new data frame is exactly the same convention as what we did before. I think one thing that maybe you find a bit weird is that under count, rather than telling you 18 as an integer, it says 18.00000. Of course, if like me, you don't like to have 18.00 and so on, if you just want to know the integer, you want to have access to an integer, which is 18, meaning there are 18 rows, you can get that also from count. So if you take the count function and apply it to the data frame, then it tells you how many rows there are for each column. That were our first steps. Let's now have a look at how to visualize data from a Pandas data frame.